EnCharge AI's EN100 chip, the future of on-device AI edge computing breakthrough. Imagine a world where your phone, car, or even a tiny drone can run the same powerful AI that today needs a warehouse full of servers without ever touching the cloud. That future just took a giant leap closer, and it's coming from a quiet lab in California. But here's where it gets controversial. Some engineers swear this new approach will make today's digital chips look like steam engines, while others argue it's too radical to trust. Which side will you land on? EnCharge AI, a startup born out of Princeton University research and now headquartered in the heart of Silicon Valley, has officially pulled the wraps off its EN100 AI accelerator. At first glance, it looks like any other sliver of silicon. Yet under the hood, it abandons the 70-year-old fetch, decode, execute routine that every conventional processor still follows. Instead, the EN100 stores data and performs calculations in the very same physical location, an analog in-memory computing fabric that can scale from a smartwatch to a satellite without rewriting the software. The timing is no accident. Roughly 12 months ago, EnCharge inked a strategic partnership with DARPA, the Pentagon's famed moonshot factory, to harden the technology for defense-grade reliability. That collaboration gave the team access to bleeding-edge process nodes, radiation-hardening tricks, and real-world mission scenarios most startups only dream about. The result is a chip that can deliver more than 200 TOPS, that's 200 trillion operations every single second, while sipping power so gently it can run on a battery you could balance on your fingertip. Naveen Verma, EnCharge's CEO and a Princeton professor who has spent nearly 2 decades rethinking how electrons can do math, didn't mince words when we caught up with him on the season opener of the Aerospace Defense Technology podcast. EN100 isn't an incremental tweak, he told us. It's a clean-sheet rethink of what an AI computer should be. We've de-risked the idea across 4 generations of test silicon, and now we're handing it to industry as a fully programmable, drop-in inference engine that shatters the energy wall digital chips keep hitting. Translation for non-chip geeks: instead of shuttling data back and forth between separate memory and processor blocks, a commute that burns 90% of the energy budget, the EN100 does the math right where the weights live. Think of it as turning every bookshelf in a library into a tiny librarian who can answer questions without ever leaving the aisle. The payoff is that advanced neural networks, think real-time language translation, hyper-personalized health diagnostics, or autonomous navigation, can live entirely inside your device. No cloud required. That means lower latency, stronger privacy, and zero risk of a network outage, turning your gadget into a paperweight. And this is the part most people miss, because the architecture is analog. It's naturally tolerant of the tiny imperfections that plague ultra-small transistors. In plain English, the chip actually gets more reliable as it shrinks, the exact opposite of what happens with traditional digital circuits. If that claim holds at scale, it could flip decades of semiconductor wisdom on its head. Want to dive deeper? Verma walks us through live benchmarks, radiation test footage, and even a demo of a drone running YOLO object detection at 4K 60 FPS on a single EN100. No heatsink, no fan, no cloud. You can catch the full conversation by subscribing to the Aerospace Defense Technology podcast on Apple Podcasts or Spotify, links below. Apple, https podcasts, Apple Podcasts, Aerospace Defense Technology ID, 172964421. Spotify, open spotify.com/show2mddenim61bmagurk. Is analog in-memory computing the holy grail of edge AI, or are we trading proven digital precision for a sexy science experiment? Will the first security flaw send us running back to the comforting zeros and ones of yesterday? Drop your take in the comments. Would you bet your next product on a chip that thinks in shades of gray instead of black and white?